Another type of sequence you're going to look at in the course is a geometric sequence. So the generalized formula for the geometric sequence is as follows, and hopefully you'll see that you're not adding anything in there, you're multiplying. So it's mostly a multiplication, and that's the property we're going to look at in geometric sequences. So this is a general formula, and I'm just going to go through the definitions. The R is called the common ratio. So that's the common ratio. This is what you're multiplying every time. So every time you want to get a new term, you're multiplying by this common ratio, or the difference between your terms is this common ratio. And we call it ratio because in order to find it, you have to divide between a term and the previous one. So the division gives you the ratio between them. That's the only new definition in comparison to arithmetic sequences. Otherwise, the n still refers to the position of the sequence. So if I'm talking about the first, second, third position, I'm going to write it in the n space. And un refers to the term itself, so the actual number. And the n in that un refers to the position of the number. So if I say u5, I mean the fifth term in my sequence. So the sequence here, for example, if you notice it's not an arithmetic sequence, you're not adding a common difference. What we are doing though is multiplying. So the starting term is 5, and what we're doing is we're multiplying by 2 every single time. So we're multiplying by 2, and so on. So, and this can be easily spotted, but in case you can't spot it, you can always take the one term and then divide it by the previous term. So I can take 10 divided by 5, that will give me 2. I could do the same thing here, this divided by 20, and that will give me 2, which is why we call it the common ratio. So the common ratio is R. We don't call it the common difference. So the common ratio is 2. It's good to know that notice that the starting number is 5, and then the sequence is infinitely increasing. So, and that can be seen by the dotted lines here. This is just an observation. So using these two, I can write the general formula. So if you can notice here in the generalized formula, we have the u1, which is the first term, and we have the common ratio to the power of n minus 1, and that's what we're going to do here. So the general term for this sequence is 5, which is our starting number, times 2, which is the common ratio to the power of n minus 1. And we can substitute a few values in there just to check that we are correct. So for example, if I want, so this is my first, second, third, fourth number. Let's look at u4, and that's going to be 5 times 2 to the power of 4 minus 1. And that's going to be 5 times 2 to the power of 3. 2 to the power of 3 is 8. 5 times 8 is 40. Okay, so we've got the number. And do note that the power only belongs to the common ratio. The power does not belong to the 5. And therefore, I have to write this multiplication sign between them just to separate them. Otherwise, it would look like the n minus 1 belongs to both. So make sure that you evaluate the exponent first, and then you deal with the multiplication. So that's one example. Another example is here. Take a few seconds to notice what the common ratio is. So you'll notice that you're dividing by 2 every single time. But instead of saying divide by 2, notice that I've always said the common ratio is what you're multiplying with. That's what I wrote in the first slide. So we don't want to say divide by 2. We want to say a multiply by a half. So when we're talking about common ratio or the R, always think about multiplying. Okay, as I mentioned in the beginning. Even if you have something like divide by 4, that's going to be a multiply by 1 over 4. And again, if you can't find it, you can always take the 100 divided by the 200. So 100 divided by 200, and I can simplify this to 1 over 2. So I can tell that my ratio will be 1 over 2. Same thing here. I'll take 25 divided by 50, and that will give me 1 over 2. So this common ratio can be found through the terms or through observation, but be careful, always divide the future term by your previous term, or the front term by the previous one. Don't be tempted to do, bigger number divided by smaller number. No, it's always the next term divided by the previous one. So we have our common ratio, we have our starting number. This sequence is decreasing infinitely. It's going down, and it's infinitely because I have these dotted lines in there to indicate it. So I can write my generalized formula as 200 multiplied by a half to the power of n minus 1. If you have a fraction, make sure you put a bracket around the fraction so that you have the n minus 1 in there, indicating that it's for the whole fraction. And we can again check that we will get the value. So let's say this is 1, 2, 3. Let's say I want to get the third term. That's 200 times a half to the power of 3 minus 1. That's going to be 200 to the power of times 1 over 2 to the power of 2. And 200 times, I'm just going to continue here, 200 times 1 over 2. So you give the power to each of the terms in the fraction. So that's going to be times 1 over 4. 200 times 1 over 4 is the same as saying 200 divided by 4. So that's just going to be a quarter of it, so that's going to be 50. So there are some questions. I'm going to go through these quickly, but this is when like the first term or the common ratio is missing. So I'm going to deal with when different things in the formula is missing rather than the term itself. So pause and read the question, but here's how I would summarize it. So I know that the second term is -5, fifth term is 405. I'm going to use the formula because that might help me find the first term and common ratio. So the formula is going to be u1r n minus 1. My n is 2 because this is the second term. And in here my n is 5 because this is the fifth term. So I'm going to simplify it to get this. Now, this looks like simultaneous equations, but you do not solve it like simultaneous equations. Because your values are multiplied, because your unknowns are multiplied, what we're going to do is we're going to divide them. So you're not going to solve them like the usual simultaneous equations. So you're going to divide your value, you're going to divide the fractions with each other instead of adding them or subtracting them from one another like you usually do. So it's the same process, but it's division instead. And what you want to do is you want to take the bigger term, the one with the highest r power, and divide it by the other one. So I'm going to go u5 divided by u2. Now, u5 is 405, and my u2 is -15, so that's what I'm going to divide. And my 405 is precisely this expression. So I'm just going to say that's also equal to u1 r to the power 4 divided by u1 equals to r. All I did was kind of copy the u5 divided by u2, and I've just put the exact values in there, and they're all just equal to each other. These are three different representations of the same numbers. So then what I will do, hopefully you'll notice that you can cancel out the u1, and that's what we want to do. We can also reduce the powers, so the power 4 will be 3, and it will cancel out with this r. I can also simplify this left-hand side. So I'm just going to deal with kind of this section. My left-hand side is going to simplify to a -27, and my right-hand side is going to simplify to r cubed. So this is what I'm left, which is great. I only have one term now. Now I'm going to take the cube root. So if you have a 2 in there, you take the square root. If you have a 4 in there, you take the fourth root. For a 3, I'm going to take the cube root. So a cube root of 27, and r is equal to -3. So now that I found the r, same thing with simultaneous equations. You're going to substitute the r in any of these expressions. So the first or the second one, I'm going to substitute in the first one. That's easier. So I'm just going to put -3 instead of the r, and that's going to give me u1 equals to 5. And you can double check your answer, substitute it in the second one, and make sure that the r and the u1 you picked will give you 405. Now, what if the n is missing? So this will be slightly different. So find the number of terms. This is the n. So pause the video, read the question again. So if it tells you the last term of the sequence is 2, so we have 5, we have something, we have 1 to 80, and then we continue and we have 20,480. Okay, so this is our last value. So this is going to be un. We don't know what this is, the u5, and this is u1. So what we want to do is find the n value here, because this is our last term. So this will tell us how many terms there are in the sequence. So we're going to write the formula for u5. We don't need to write the formula for u1 because it's just the first term. So u5 is 1,280, which is u1, and in this case that's 5, times r to the power 5 minus 1. That simplifies to r to the power 4. So I can easily solve this. I don't need a simultaneous equation. I'm just going to solve it, and it's going to give me this. Now, if I take the fourth root of 256, because I'm taking an even root, it has to be a plus minus. So that be, sorry, because I'm taking, an even root, it has to be a plus minus option. But notice how the question said, given that r is positive, so therefore r is just equal to 4. So that always happens with a positive root. So now what I'm going to do is we need to find un, and we know that un is basically u1 times r to the power of n minus 1. I have u1 and I have my r. So I'm just going to substitute them in there, and I know that un is 20,480. Now, what you could do it two ways. Either use a calculator for this, so what you're going to do is you're going to put the geometric general sequence in the calculator. You're going to go to y equals, and you're going to put it in there. So the way to get the x is by pressing this button, the xt theta n. And then what you're going to do is you're going to go to second and then table or graph. And what we want is we want to see when is it equal to 20,480. So we're going to go all the way down and see that, oh, when x is equal to 7, so that means when our n is equal to 7, our output is 20,480. So I can simply say n is equal to 20,480. That's if you haven't studied things like logarithms and stuff and you already have your calculator in this paper. Alternatively, we could do the following. We can actually simplify it. So first divide by 5. Do not divide by 4. You first want to get rid of the 5. And then what you're left with is going to be 4 to the power of n minus 1 equals to this. Now what you're going to do is something called using logs. And if you're not comfortable using it, ignore this step. You can use a calculator. So what you're going to do is take log of 4,096 divided by log of 4, so log of the thing that has the power. And you're going to take the power and put it in as a term on its own. Simplify this using a calculator, and that's going to give you 6. So n minus 1 equals to 6. Simplifying it, that means that n is equal to 7. So these are some of the examples you might get with geometric sequences, but finding the number of terms you will have to use the calculator for, because it's always a power, so either the graph table or using logs. Otherwise, just be careful with simultaneous equations. You are actually going to divide the terms rather than adding the general terms together.